Hello, I'm doing this video for you to review how to balance an equation. So the first thing that you need to know to understand this type of exercises is that atoms can neither be created nor destroyed. So this means that they only mix with other elements, okay? So you need the same number of atoms in the reactants and in the product. For example, in this exercise, you have potassium, you have chlorine, and you have oxygen. So in here, we're going to do like a draft that we use to count how many atoms do we have in each side, okay? So in the left side, I have how many potassiums? 1. How many chlorums? 1. And how many oxygens? 3, okay? So I'm going to put like 1 potassium, 1 chlorum, and 3 oxygen. And in the right side, I have 1 potassium, 1 chlorum, and 2 oxygens. So I'm going to put like 1, 1, and 2. So you see that I have the same number of potassiums in both sides, the same number of chlorums, but I have a different number of oxygens. So this is incorrect because it means that if at the beginning I have 3 oxygens, at the end I also need 3 oxygens because I can't destroy the oxygens, okay? I need the same number of them. I need a balance in both sides, okay? So there's a trick, which is when you have like 3 and 2, you can exchange the numbers. So I can put in here like a 2 and in here like a 3. And this number that I put in here, remember that is called like stoichiometric coefficient, and this number that you put in here, it means that you have twice this molecule and 3 times the O2. So this number here is going to multiply. It's going to multiply the potassium, it's going to multiply the chlorine, and it's going to multiply the oxygen. So if it multiplies, now you have in here how many potassiums? Instead of 1, you have 2. How many chlorums? Instead of 1, you have 2. And if you have 2 times 3 oxygens, instead of 3, you have 6 oxygens. And if in the right side you put also 3 oxygens, now this 3 is going to multiply these 2, so now you have 6 oxygens. So as you can see, you have 6 oxygens here and 6 oxygens here. So the oxygens are balanced. And now you have to try to fix the chlorums and the potassiums. And how do you do it? You can put in here a number 2. So now you have 2 potassiums and 2 chlorums. So now this is balance, okay? And the result would be this one. Remember that this is only like a draft that we do to practice. It's not necessary to put this in the final answer, okay? The final answer would be this, 2, 2, and 3. Okay, let's do a second example now. So in this one, I have hydrogen, chlorine, aluminium, and oxygen. Remember that if I have like a capital letter and a small letter, they go together, okay? If I have like 2 capital letters, they are separated atoms. Okay, so let's count. In the right, I have 1 hydrogen, 1 chlorine, 1 aluminium, and in here careful because if I have brackets, these 3 affect the oxygen and affects the hydrogen. So I have 3 oxygens and in here also 3 hydrogens. So in total, how many hydrogens do I have? 3 in here and 1 in here. So I have 4 hydrogens in the left side. And I have 1 chlorine, 1 aluminium, and 3 oxygens. I have in here 3 oxygens, 1 aluminium, 1 chlorine, and 1 hydrogen. Okay, so let's count how many do I have in the products. So in the products, I have 1 aluminium, 3 chlorums, 2 hydrogens, and 1 oxygen. Remember that if I don't have any number in here, it means that I have only 1 oxygen, 2 hydrogens, 3 chlorums, and 1 aluminium. Okay, so 1 aluminium, 3 chlorums, 2 hydrogens, and only 1 oxygen. So this one is a little bit more tricky, okay, because I have like 4 elements and I have like, you see that only the aluminium is balanced, so I'm going to have to change a lot of things, okay? So maybe I can start trying what happens if I put like a number 2 in here. So if I put a number 2 in here, I'm going to see that this number 2 is going to multiply the hydrogen. So I'm going to have like 4 hydrogens and 2 oxygens. But you see that it's still not enough because I need 3 oxygens and 2 oxygens. I need 3 and I also only have 2 in here. So this is incorrect, okay? I see now that this 2 doesn't work. So I'm going to try with a different number, okay? What happens if I put a 3 in here? If I put a 3 in here, now I have, like, this 3 is going to multiply the hydrogens, and this 3 is going to multiply the oxygens. So I have 6 hydrogens and 3 oxygens. Okay, so far the oxygens are balanced, the aluminium are balanced, but this one, no. Okay, so as you can see, I need 3 chlorums in here, and in here I only have 1. So I'm going to try putting a 3 in here, okay? So if I put a 3 in here, the 3 affects the hydrogen and affects the chlorum. So now I have 3 chlorums, and I have in this side 3 hydrogens and plus these 3 hydrogens. So in total, in the left side, in the reactants, I have 3 plus 3, 6. So 6 hydrogens. And as you can see, now I have everything balanced. 6, 6, 3, 3, 1, 1, 3, 3. Okay, so as I told you, the final answer would be this, okay? 3, 1, 1, and 3. This thing here is not important, okay? You can erase it later. I'm going to explain now a different technique that you can use to solve this type of exercises, okay? Remember that you can solve these exercises just by trying. You try different numbers. If it works, you continue that way. And if it doesn't work, then you erase it and you try with a different number. This is just like trying, okay? But there's another technique that it is using algebra that is going to give you directly the final solution. This technique is a little bit more tricky, so you can use it like for equations that are difficult to solve when you try with different numbers and you are trying and trying and trying and you don't get to the final solution. You can use this technique, okay? So in this technique you have like one element, another one, and another one. Okay, so you're going to call the first one A, the second one B, the third one C, and the last one D. Okay, so now you have to write how many types of atoms do you have. So you have carbon, you have hydrogen, and you have oxygen. Okay, so in the first one, in compound letter A, in the compound A, I have 1 carbon and 4 hydrogens. So I'm going to put like 1 carbon, okay? Like in A, I have 1A. As I have 1 in A, I can already put like also only A, okay? So I have 1 in A. And then in B, I don't have any carbons. So I'm going to put equal to. In C, I have only 1 carbon, so I'm going to put that A, it is equal to C. Okay, and now let's see the hydrogens. The hydrogens, I have 4 hydrogens in A, so I'm going to put like 4A is going to be equal to, where else do I have hydrogens? I have hydrogens in D. So in D, I'm going to put like 2D, because I have 2 hydrogens in the D, okay? So now I'm going to count the oxygens. I have 2 oxygens in B, so 2 is going to be equal, so 2B is going to be equal to, and now I have 2 oxygens in C and 1 oxygen in D. So the oxygens that I have in the reactants have to be equal to the oxygens that I have in the products. So the oxygens that I have in here had to be equal to the oxygens that I have in here. So 2B is going to be equal to 2C plus D. Why? Because I have 2 oxygens in C and 1 oxygen in D. Okay, so now I'm going to give value, I'm going to give one value to one of the letters. Okay, so I'm going to say, for example, that if A is 1, this number is a number that I make up, okay? But it is better if I start like with a small number. Usually we start with 1, okay? like to make the calculations easier. Okay, so you start saying like A is 1. You can also start saying that B is 1 or C is 1. Like, it doesn't matter, okay? So if A is 1 and we know that A is equal to C, this means that 1 is equal to C. So C is also going to be 1. Okay, so if A is 1, then C is also 1. Okay, so then I have in here another equation, which is 4A is equal to 2D. And if we are saying that A is 1, I'm going to put that 4 times 1, it is going to be equal to 2D. So in here I have to discover how much is D. So 4 divided by 2 is going to be 2, and this is going to be equal to D. So D is going to be 2. Okay, and now I have to solve this one. So I already know A, C, and D, but I'm missing B. Okay, so I'm going to solve this one. So if I know that 2B is equal to 2C, but I already know that C is 1, I can put like 2 times 1 plus D, and I know that D is 2, so 2. So 2B is going to be equal to 2 times 2, which is 4. So B is going to be equal to 4 divided by 2, which is going to be 2. So B is 2. Okay, so this means that A is 1, B is 2, C is 1, and D is 2. So what am I going to do with these numbers? This means that in A, I'm going to have to put 1, the number 1. If it's 1, it's better if I don't put anything, okay? So I don't put anything in here. And in the second one, I'm going to put 2, because B is 2, and then D also 2. Okay, so this is going to be my final solution. Let me put it in red because it looks better, okay? So this is going to be my final solution. So I did all of this using algebra to find the final solution. Okay, so sometimes it's easier just to try with numbers like we did in these two cases, okay? But when the equation is very difficult, we can keep trying with numbers and we're not going to find the final solution. We can apply this technique, which this technique is never going to fail us, okay? But you see that sometimes it can be tricky because you have to use equations, you have to solve them. So you can choose the technique that you want, okay? You can start applying this technique, and if you have questions, if you don't understand or you don't get to the final answer, you can apply this technique, okay? So I hope this video was useful for you, and you can keep practicing with the exercise that you have in classroom. Bye.